Hello and welcome. Today, we're diving into a really fascinating puzzle at the heart of the AI revolution. It's a question that, on the surface, seems to have an obvious answer, but it doesn't. I mean, think about it. You've got these incredibly powerful AI tools literally just an API call away. They're amazing. So why on earth would a big company go through all the trouble, all the expense, of building its own from the ground up? It sounds kind of crazy, right? Well, as we're going to see, the answer has less to do with technology and everything to do with control, security, and long-term strategy. And the answer really boils down to this one powerful concept: AI sovereignty. It's the idea that for your company's most important work, you need complete ownership. We're talking end-to-end control over the model, the data it's trained on, and, this is key, the valuable insights it creates. It's not just about having a tool, it's about building a deep, strategic advantage that your competitors just can't buy off the shelf.
So that leads us right to the fundamental choice here. Should you treat AI like a utility that you just rent, like electricity? Or should you treat it as a core part of your business that you need to own and master?
So let's break down that trade-off. Renting AI from a cloud provider is super convenient and it's cheap to get started. It's fantastic for general, non-critical tasks. But here's the problem. You're totally dependent on that vendor. What happens if they change their prices? Or even worse, what if they get rid of the model your entire workflow is built on? You're stuck. And you can forget about deeply customizing it with your own secret sauce, your proprietary data. For a company's crown jewels, we're talking its intellectual property, owning your AI on-premise is the only way to go. It gives you absolute security and control, making sure your most valuable data never leaves your building. For some industries, that's just non-negotiable. Okay, but I know what you're thinking. What about the cost? Surely building your own AI is just astronomically expensive? And yeah, it can be, but the real financial story is a lot more interesting than you might think. Let's actually run the numbers. Okay, just look at this number. For what we call a moderate workload, about 50 million tokens a month, using a public cloud service could easily cost you $250,000 a year. And the scary part is that cost just keeps going up and up the more you use it. All of a sudden, renting doesn't sound so cheap anymore, does it? This whole situation brings us to a classic business showdown: CapEx versus OpEx. Owning means a big upfront capital expenditure. You're buying the hardware, the GPUs. Renting, on the other hand, is all operational expenditure. It's a pay-as-you-go subscription that looks really attractive at first, but as we just saw, it can quickly turn into a financial runaway train when you start to scale. But check this out. When you look at the total cost over the long term, the whole story flips. Yeah, in year one, renting looks a tiny bit cheaper. But look what happens. By the end of year three, the on-premise model you own is already saving you hundreds of thousands of dollars. And by year five, you've saved almost $1 million. That break-even point, somewhere between year one and year two, that's the magic moment where owning your AI starts paying you back in a huge way. So what's the catch? Because there's always a catch, right? Well, here it is. For the own model to make financial sense, you absolutely have to keep that expensive hardware working. The entire argument falls apart if your GPUs are just sitting there gathering dust. You've got to hit a utilization rate of over 60, maybe 70% consistently. That is the single most important factor in making this work. Okay, so if owning is financially smarter and strategically a must-do, how in the world do you actually make it practical? I mean, you can't just stick one of those giant city-sized AI models in your server rack. You need a way to make it smaller, faster, and cheaper to run. And luckily, there was a really clever way to do just that. It's called model distillation. And I have to say, the analogy is just perfect. Imagine you have a giant, incredibly wise teacher model. Think something like a GPT-4. You then use that teacher to train a much, much smaller student model. The whole goal is to pour all of the teacher's knowledge into the student, creating this tiny, efficient, specialized genius. Now here's how it works, and this is the secret sauce. The student isn't just copying the teacher's final answers. No. The key is that the student is trained to mimic the teacher's reasoning, all the probabilities and the thinking that happens behind the scenes. And by learning how the teacher thinks, this little student model can achieve something incredible. Up to 97% of the teacher's performance, but on one very specific task, all while being a tiny fraction of the size. But wait, how do you do this distillation securely? You don't want to send your secret data up to the cloud, right? Well, this is the really genius part. You use a hybrid cloud burst workflow. First, you do the heavy lifting, the training of the big teacher model, up in the cloud. But you only use generic, non-sensitive data. Then you download that trained teacher into your own secure local environment. Then and only then you run it against your sensitive proprietary data to create a private training set. Finally, you train your little student model entirely in-house on that secure data. You get the best of both worlds, the power of the cloud with the security of your own data set.
So let's take this one step further. We've figured out how to create these small, highly specialized expert models. Now what happens when you get them to work together as a team? You get to build an AI swarm.
Now, the fancy formal name for this is a hierarchical multi-agent system, or HMAS. And this isn't science fiction, by the way. This is a well-established architecture you see in cutting-edge frameworks like MetaGPT. The idea is simple. You have a manager AI that acts like a project lead. It takes a big, complex problem, breaks it down into smaller pieces, and then delegates those pieces to a team of specialist AIs. I want you to think of it like an orchestra. You've got the orchestrator model. That's your conductor. It's a reasonably smart model that plans the whole performance and delegates the tasks. Then you have your specialized agents. Those are our tiny, distilled models. They're the musicians, and each one is a virtuoso on a single instrument, whether that's writing SQL code, analyzing a document, or making an API call. And what do they all work from? The sheet music, which is your company's own databases and knowledge. And what makes this system so incredibly robust is this plan, act, correct, verify loop. It's not just a dumb chain of commands. The orchestrator makes a plan. An agent tries to do it, but if it fails, if it hits an error, a special corrector module kicks in, analyzes what went wrong, and tries a new approach. It's self-correcting. This creates amazing resilience and stops one little mistake from derailing the entire complex job. So when you put this all together, what you've really built is an AI factory. It's a pipeline. You fine-tune a big open-source model on your own high-quality data to make it an expert. You distill that expertise down into a small, efficient student. And then, for maximum performance, you quantize it. Basically, you shrink it down even more so it runs lightning fast. This is how you mass-produce the custom little agents for your swarm. Now, this all sounds absolutely incredible. Maybe a little too incredible. And you're right to be skeptical, because it is not magic. Building this kind of system comes with some very real, very serious challenges. So let's have a reality check. First, and this is the big one, the data gap. We've all heard it, garbage in, garbage out. And that is the absolute law of the land here. If you don't have high-quality, clean, well-labeled training data, this entire thing is dead on arrival. Second, the MLOps overhead. The swarm isn't a single program, it's a complex system that needs constant monitoring, testing, and support. And finally, you have to understand what these small models are. They are brittle. They are amazing specialists, but they are not generalists. Ask them to do something even slightly outside their narrow training, and they can fail in some pretty spectacular ways. And here's a hidden gotcha that trips up so many people. Licensing. You have to understand that not all open source licenses are the same. A model like Llama 3, for instance, is great, but it has rules. You can't use it to train a competing model, and there are restrictions for really big companies. For true business flexibility, especially if you ever think you might want to sell a service built on this, a license like Apache 2.0 is often a much safer bet. It's super business friendly and even protects you from patent lawsuits. It's a detail, but it's a crucial one. And finally, there's the ultimate goal for many companies, taking this incredible internal tool and turning it into a product you can actually sell to clients. And let me tell you, that is a monumental leap. You have to solve incredibly complex problems like making sure one customer's data is totally isolated from another's and building an infrastructure that can scale to serve hundreds or thousands of users. It's the North Star you aim for, but it is a very, very long journey to get there. So all of this leads us back to one big final question. As AI becomes as fundamental to doing business as the internet or electricity, who do you think the real winners are going to be? The companies that just treat it like a utility they rent month to month, or the ones who achieve true AI sovereignty by building, owning, and mastering their own AI destiny? That is the billion-dollar or maybe trillion-dollar question every business leader should be asking themselves right now. Thanks for joining us.